Okay, so we just started that investigation. So can you guys tell me the first two commandments of exponents? What are they? If you have a situation where the bases are the same regardless of what they are, that's why I just called them A. And the exponents are some number, could be anything, m or n. What do you do?
It's equal to a to the power of n plus n.
So you add the exponents in that case in order to pull those two things together. Yeah? So that's what I call the first commandment of exponents. You're like, okay, maybe it's just for now. This is almost like in everything algebraic from now on. Like it's all over the place. Okay, how about this one? This is the commandment I like to say, power to power. So you have one power, and then you're raising that expression to another power. If you have a power to power expression, how does that go, Sierra?
Isn't it a to n times n?
Yes, you multiply the exponents. That's key. That's the way I remember. The way I remember these, and don't mess them up, is I just always ask myself every problem, like when I start looking at things like this, I'm like, is it power to power? If so, it's multiply. It's pretty much always add if it's not power to power, okay? We're going to see another one where there's a subtraction, but that one's obvious. Like, it's never confusing to pick which one it is, so.
PEMDAS also applies with that. Like, if you do the power inside the PEMDAS,
Yeah.
then the power.
Yeah, it is kind of like PEMDAS. Very good, Lindsay. I like that. Good. So the four problems that were at the bottom of that first part of the investigation, let's see. So ask yourself, is this power to power? Yeah, so I should do what with the exponents? Multiply them. So this is 5 to the 30th. Done. That's some huge number. We'd probably want to use scientific notation if the calculator gave it to us. I bet your calculator does put it in scientific notation. Try it. If you put that in there, I bet it's going to give you the E thing we were talking about. All right? How about this guy? Is this power to power? That's how I decide on almost everything. Is this power to power, guys? No. So it's probably the other one where you're adding, so you get what, 15? Is this guy power to power? Kind of, but you got to use PEMDAS, like Lindsay said. Go inside first. Inside, there's 2 3s. What's the power on this one technically?
1.
There's a 1. So what do you do with those? You add 3 plus 1. That's 3 to the 4th. And then you've got another layer, which is power to power. So now I multiply. You get 16th power of 3. Does that make sense? Okay, here's another one. I've got 2 different pieces, so I'm going to do them separately. This first term, I've got power to power, right? So I multiply. And then coincidentally on this guy, these are the same kind of things. It's like you've got 2 apples. So 2 of them. Yeah? It's just like 2x. That's like x plus x. X and x are the same. 9 to the 21st power is the same as itself. So there's 2 of them. I bet most people didn't put 2 of them there, but you could. Okay? All right, what if you have variables in your work? Because a lot of your problems are going to have variables. Is it really going to be any different? No. I mean, like numbers and variables work the same way with this stuff, so don't let them scare you. So here, we might have to do a couple steps, but let's see. So this part's power to power, right? So I multiply the 4 and the 6. What is that? 4. And I've still got a squared there. And now it's just like the first one was. So same base. I add the exponents. So that's 26th power of x. I'd much rather work with this than this ugly thing. This is just the 26th power of x. This is, I'm not sure, you know? All right, let's do this guy. So this guy, I think I'm going to do the power to power parts first. So I'm going to leave the y alone. Power to power is multiply, so that's 12. Power to power here, even if there's a negative exponent, we started working with negative exponents, right? What was negative exponent code for? Can you guys help me? Was it negative?
It was fractions.
It was fractions. It was code for move, right? Move. But let's just ignore that first. So power to power first means multiply and get negative 6th. And now, could you move that? So this is kind of a lead into next week, but we can do it. That has a negative exponent, so it should be moved to the bottom and become x to the 6th. And then we're going to investigate this case next week. That's on the back of your worksheet. Anybody care to guess what this is going to reduce to? Y is going to be y. It's x to the 6th. Because if you write this out, think about it in your head real quick. How many x's are on top times each other?
12.
12. It's x, 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 x. On the bottom, there's x, 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 x. A whole bunch of them are just going to cancel each other out. And how many are going to be left? 6 of them will be left on top. So we'll investigate that more thoroughly on Monday. Here's one last one. So everything's multiplied. If you've got everything multiplied and there's some numbers in there, take care of your numbers first. You know what I mean? So I've got a 3 and a 5. That's 15. It's all multiplied. Then I'm going to put my stuff that's the same together. So I'm going to put my m's all next to each other. You guys see what I'm doing? Changing stuff around, putting stuff that's the same next to each other. So then there's an n there, and there's an n there. And now we can use our first commandment. So 15 is 15. All of these guys get added up. So how many m's are there? There's 7 m's, 2 m's, 3 m's, all multiplied. We add them all up. We get 9 plus 3 is 12 m's. And how many n's? 9 m's. Done. Okay? So I think that's about all you do. If you run into ones that have negative exponents, especially if you're in group A, I'm going to kind of expect you to resolve those. Okay? That means move to the bottom and then try to resolve it. If you left this one like right here, I'm going to be happy, but that's the answer, and I'm thinking you can probably figure that out. Yeah? We'll look at that more on Monday, though. All right.